So this lecture is one on one-shot neural architecture search. So very important. It's a technique in the field of machine learning and deep learning that aims to efficiently discover optimal neural network architectures. Unlike traditional neural architecture search methods that require training and evaluating numerous candidate architectures independently, thus demanding substantial computational resources. So, unlike traditional NAS methods that require training and evaluating numerous candidate architectures independently, thus demanding substantial computational resources, one shot NAS significantly reduces computational costs by sharing model weights among different architectures during the search process. So, by sharing model weights among different architectures during the search process. So, what happens? Core concepts of one shot NAS neural architecture search supernet representation. This is the fundamental thing. So one shot NAT in NAS involves constructing a large over parameterized model called supernet. It's an over parameterized model called supernet which encompasses all possible architectures in the search space. So very interesting concept. Each candidate architecture is then represented as a subnetwork of this supernet. Each candidate architecture is then represented as a subnetwork of this supernet. Now, weight sharing. Weight sharing, instead of training every candidate architecture from scratch, the supernet's weights are shared across all subnetworks. The subnet's weights are shared across all subnetworks instead of training every candidate architecture from scratch. During training, only the weights corresponding to the active subnetwork, the architecture being evaluated, are updated. Search strategy. A search algorithm, reinforcement learning, evolutionary algorithms, or gradient based methods is used to explore the architecture search space. The performance of a candidate architecture is estimated by evaluating it within the supernet using the shared weights, avoiding the need for full training. The performance of a candidate architecture is estimated by evaluating it within the supernet using the shared weights, by evaluating it within the supernet by using the shared weights, avoiding the need for full training. Now, efficiency. This method drastically reduces the time and resources required for NAS, making it feasible to perform architecture search on large datasets and complex tasks. The advantages of one-shot NAS. Computational efficiency. By sharing weights, the need to independently train each candidate architecture is eliminated, reducing the overall computational cost. Scalability enables the exploration of large complex search spaces that would be infeasible with traditional NAS methods. Flexibility compatible with various search strategies such as gradient based approaches, reinforcement learning, or evolutionary algorithms. So, it is compatible with various search strategies such as gradient based approaches, reinforcement learning, or evolutionary algorithms. Challenges of one shot NAS. Weight interference. Since weights are shared among different subnetworks, the performance of one architecture might be influenced by others, potentially leading to suboptimal results. Training bias. Certain architectures might dominate the training process, leading to an uneven exploration of the search space. This is an important point. Certain architectures might dominate the training process, leading to an uneven exploration of the search space. Approximation error. Evaluating Evaluating architectures with shared weights may not accurately reflect their true performance when trained independently. This is also an important point. Now, popular one-shot NAS methods: differentiable architecture search. It uses a differentiable relaxation of the architecture search process, enabling gradient-based optimization. To differentiable relaxation of the architecture search process. Efficient neural architecture search employs reinforcement learning with a controller to sample architectures from supernet and trains the supernet with shared weights. It employs reinforcement learning with a controller. To sample architectures. Reinforcement learning with a controller to sample architectures from the supernet and trains the supernet with shared weights. Single path one shot. This simplifies the supernet training process by sampling single paths, that is, candidate architectures, and training one at a time. Proxyless NAS focuses on hardware aware search and directly evaluates architectures on specific devices without relying on proxies. Applications of one shot NAS. Image classification efficiently finds architectures for tasks like CV10 ImageNet. Object detection and segmentation extends NAS to tasks requiring more complex network designs, such as yellow based detectors. Neural architecture for edge devices, who optimizes models for deployment on resource constrained devices. This one-shot NAS represents a major leap forward in the efficiency of neural architecture search. By leveraging weight sharing and supernet training, it democratizes NAS, making it accessible for a broader range of researchers and applications. However, challenges like weight interference and training bias still require further research to fully unlock the potential of this technique. Thank you.